We are clear about the diffusion? Who knows about active transport? Come on. I want to know the qawanin for the active transport. Basic principles. From against the concentration. Awwal. Very nice. Okay. The special form of energy, direct and indirect form of energy of ATP derived energy or GTP derived energy, some source. Okay, good. Energy requiring. Yeah? Change the word. You're right. Yes. Okay. Change the word receptor to carrier. It needs some support. Just like facilitated diffusion, it attaches and it needs a carrier. Protein. Okay, so three conditions. Again, repeat the condition. Number one, against. Number two, energy. Number three, carrier. Against, energy and carrier. Pass. This is active transport. Three principles of active transport. Very quickly. Can you give me the types of the active transport very quickly? Oh yes, the diaphragm, you have studied that. Okay, the first one is, okay, you call it the primary active transport. And the second one is secondary. Can you give the difference between the two? Three conditions are same for them, both, because it's active transport. What's the difference? Primary.
What is the
One needs energy directly from ATP when the ATP breaks or the GTP breaks or any molecule breaks, and release of energy is used by that mechanism. You call it the primary. Very good. Lovely example. Thank you. The best example is sodium potassium pump. Pump. Primary is pump. P for primary, P for pump. Remember, P for primary, and you will use the pump. I say calcium pump is modular in the body, and if I ask you is it primary or secondary, I will use the word pump. What do I mean? Okay. I say, oh, it's a hydrogen pump. So without thinking, you'll say, oh, you're talking about the primary. All these pumps require ATP directly primary. Okay. So the key word is pump you are using. Sodium potassium pump, hydrogen pump, potassium pump, any other pump of the body. Pumping means you are using direct form of energy. Remember that word. Now, secondary active transport, very quickly. Okay. Well, secondary active transport also follows these three principles, okay? But it does not require a direct form of ATP in that it is dependent on some other energy source. And that energy source is taken from some area which is Mawjood in Jawar, close to it. And that area is primary active transport. So it is depending on the primary active transport in the vicinity or in the close. Okay? So primary active transport is actually arranging some ions for it, and those ions are forming a gradient, and that gradient is helping the transport. Okay? So energy is used, but in a very indirect way, not the direct way. If directly ATP is used, you call it, and if it is taking a help of some other energy source which is primarily using the energy and then it is taking the advantage, then you call it the secondary. Okay.
So can you repeat the active transport principle?
Yeah, the first principle is the active transport always is against from low to high concentration. Okay. Second is it always requires energy in the direct form or the indirect form. Okay, from the direct source or the indirect source. Direct when I say primary. Indirect when I say secondary. Okay, and the third thing is the substance has to attach to the carrier if it wants to move from one side to the other side. Okay, so three principles of that. Alright, now look at the kidney. Kidneys are using all sorts of mechanisms. If you have a very large substance which cannot be transported by active or passive or some other, what will you do? It cannot, for example, it's a big one, it cannot diffuse. Okay? It is so big, the size is so big that it cannot pass through the membrane, through the channels, through the pores, through the carrier. It cannot attach to the carrier, it cannot do anything, and it's thinking, how do I go from one side to the other side?
Break it down.
And it doesn't want itself to break it down also. Engulfing. What do you mean by engulfing? Endocytosis and exocytosis. It means, yes, it is using endocytosis, pinocytosis and phagocytosis. For small substances, phenol, and a little larger, phabo. Okay, so they can move. The whole membrane takes the substance in and leaves it on the other side, forming a vesicle. You know that. Okay, so endocytosis, exocytosis, lovely. These are the possible ways. So now you are comfortable with the meaning of osmosis, diffusion, simple diffusion, passive diffusion, facilitated diffusion, primary active transport, secondary active transport. These terms are known to you. We have quickly revised these terms. Any confusion about the terms? No. Great. Okay. Now, look at the kidney. These are the cells of the kidney. Proximal tubule, distal tubule, anything. Okay, we are talking about proximal tubule. Look at the cells. The cells are, first of all, you identify the side. Which side is the luminal side of the cell and which side is the basal side of the cell?
The right side is the luminal.
Okay, the right side is the luminal side. And why do you call it the luminal side? Any reason for calling it?
Because there is endothelium and it is
Because filtration is happening from this side and the fluid is coming, filtrate is coming here and the reabsorption is happening from this side. So this side is facing the luminal, very nice, okay? And this side is the basal side or the opposite interstitial side because the blood vessels are modules here, interstitium is module here, okay? Look at the attachment of the cells very quickly. Attachment of the cells, okay? Are the cells attached throughout their length or only in a specific part? If the specific part, is it attached towards the apical side, the luminal side or the basal side? Attachment of the cells is towards the luminal side or at the basal side? Very good. Luminal side. Everybody agrees?
Yes.
All of you? Luminal side. Okay? It means there are gaps here. Okay? This is interstitium, isn't it?
Yes.
So interstitium is also coming here. It's coming here. Okay? Now, if you want to reabsorb the substances, you have two areas or you have two pathways through which you can reabsorb. Alright? One pathway is, okay, you can reabsorb through the cell. Yani, you can see the foldings here, the surface area of the cell. So if you are passing from this area, okay, to the membrane here, okay, this is called the transcellular pathway. You are entering into the cell. You are in the cell, you leave the other side of the cell and you are in the interstitium and you are in the blood. Plus, this is transcellular, you are crossing the cell. Something is coming from this wall in this room and passing here and it is leaving this wall and outside there is blood vessel. This is transcellular, passing through the cell. Okay? And if you don't want to pass through the cell, you will say, yeah, I have one more way to go between the cells. Let's try this side also, okay? And that is where the two cells are meeting. These are called the junctions, tight junctions, okay? Tight junctions, but they have little space or they have holes which can allow the water and the small electrolytes, okay? Sodium, potassium and chloride, all these substances can move. So ions and water can move also from the tight junctions. If it is passing into the tight junctions, alright, they are leaking and they are passing through this pathway. This is not transcellular. On the sides of the cells, so you will call it paracellular pathway. So it means there are two pathways for the movement. One is transcellular and the other is paracellular. In paracellular pathway, you are directly reaching the interstitium, isn't it? Paracellular, directly. In transcellular, you are first entering into the cell from one side, then to the other side, and then into the interstitium. Alright, you're getting this? So there is a difference between transcellular and paracellular. Okay? Which pathways? Okay, for active transport, for carriers, for those substances, they would like to use the transcellular or the paracellular? Transcellular. And if there is a simple diffusion flow of ions or water only, okay, so paracellular is an easy pathway, isn't it? So first of all, build up this concept. Okay? After that, large quantity of the fluid is modular here and ions are modular. If the large quantity of fluid is moving into the blood, in the capillary surface area, this is diffusion, okay. But it is happening in large amount, you call it bulk flow. What do you call it? Bulk flow. A special type of diffusion in which large quantity of fluid is passing, okay. It's carried away in a bulk, in a large amount, okay. So, on the other side, the bulk flow happens. So don't get confused with the term, it's easy. Bulk flow means large quantity is passing into the circulation. Okay? We are stopping here. Okay? So far, are you comfortable with the types of transport? Okay? Tomorrow, inshallah,